Hello, everybody. Today we are going to talk about simplifying radicals, and then very quickly, and then we're going to talk about the Pythagorean Theorem. So this is kind of just a review for you. We simplify radicals kind of for the same reason that we simplify fractions. Okay, we all want to get the same answer. We want it to look alike. We want it to, so it's easy to tell you have the same answer, and when you have something like 1/2 and 2/4, it's pretty easy to see that those are the same exact thing. But when you have two square roots that are equal, that's much harder to tell. Okay, so let's look at simplifying them. So we've got here the square root of 27. So what we want to do, you probably can guess that the answer to this is probably a little bit more than 5. But we want an exact value. So what we're going to do is we're going to look for the biggest perfect square that will divide evenly into 27. Okay? So that's going to be 9. Now remember your perfect squares: 1, 4, 9, 16, 25, 36, 49, etc., right? So those are your perfect squares. Now we're not going to use 1. 1 never helps us, but you want to find the biggest perfect square that you can that will go into this number, and that would be 9. So I'm going to change this to the square root of 9 times the square root of 3, because the square root of 9 times the square root of 3 is the square root of 27. Now this we can simplify. The square root of 9 is 3, so we're going to change this to 3. This we can't simplify, so we're just going to leave it. And my answer is going to be 3 square root of 3. So if I get out my calculator and I calculate 3 square root of 3 and I calculate square root of 27, I'm going to get the same answer. Okay, so now let's look at the square root of 48. Okay, so you might notice that 4 will go into 48. Okay. I could use 4, but that's not the biggest perfect square, and whenever I can, I want to use the biggest perfect square because it means I have the least work to do. So, but I can also see that 16 times 3 is 48, so I'm going to change this to the square root of 16 times the square root of 3, and the square root of 16 is 4, square root of 3. Whoops. There's my answer. Okay, now what would happen if I had done 4? Let's kind of look at this over here. So let's get these out of the way. The square root of 48, 4 is a perfect square that will go in there. And that will go in there, what, 12 times? So I could change it to this. Now the square root of 4 is 2. So that's equivalent to 2 square root of 12. But there is another perfect square that will go into 12. And that's 4. So 4 times 3 is 12. So now the square root of 4 here is 2. So this becomes 2 times the square root of 3, which is 4 square root of 3. So I end up getting the same answer if I simplify it all the way. Now some numbers, when you get the really big numbers that you're trying to simplify, it's sometimes difficult to find the biggest perfect square. So in that case, just find any perfect square, take it out, simplify the thing, and then continue to do it again, kind of like I did here. Okay, so square root of 98. Let's let you pause the video and try to figure out the square root of 98, simplify that, and then jump back on and see how you did. Okay, a perfect square that will go into 98 would be 49. It'll go in there twice. So square root of 98 is equal to square root of 49 times the square root of 2. Square root of 49 is 7 times the square root of 2, which doesn't simplify anymore, so that's as far as you're going to go. Okay, square root of 17. Well, here's the thing. 17 is a prime number. So there is no perfect square that's going to divide evenly into 17. So this is just already simplified. The answer is the square root of 17, and you're done. Okay, do not change these to decimals unless it asks you for a decimal approximation. Okay, these are exact values. You cannot get an exact value for a square root of 3 or a square root of 2. Those are irrational numbers. So if you need an exact answer, you got to leave the square root in there. Okay, so this is how you can simplify some square roots, and I got a little worksheet that I'll be giving you with a bunch of square roots for you to simplify. Okay, now let's talk about the Pythagorean theorem. So, if I have a right triangle, it's got 3 sides, of course. The 2 sides that meet at the 90-degree angle are called legs. This we'll call leg 1, this we'll call leg 2. It doesn't matter which one's leg 1 or which one's leg 2. Okay, I can switch that around, it doesn't make any difference. Now, the side that is not that does not meet at the 90-degree angle is the hypotenuse. Okay? It's always across from the 90-degree angle. So make sure that you can identify the sides. Okay? So in a right triangle, the legs are the 2 sides that meet at the 90-degree angle. The hypotenuse is the side opposite the 90-degree angle. And just for reference, the hypotenuse is always the longest side of the triangle. Okay. The Pythagorean theorem says the sum of the squares of the 2 legs of a right triangle is equal to the square of the hypotenuse. What does that mean? It means this. You take the first leg and you square it, and you add that to the second leg squared, you will get the hypotenuse squared. Okay? Otherwise known as a squared plus b squared equals c squared. Now, the reason I don't just teach this is because that's true if this is a and this is b and this is c. But if I were to switch this around and say, oh, this is a, this is c, and this is b, this is no longer true. And people will jump on it and they'll go, oh, a squared plus b squared equals c squared, and that's wrong in this case. It would be correct in this one. But if you remember, leg 1 squared plus leg 2 squared equals the hypotenuse squared, you won't miss this because you'll know, oh, here's one leg, I square that, here's the other leg, I square that, I add those 2 numbers together, and I get the hypotenuse squared. So in this case, this would be a squared plus c squared equals b squared. Okay. So how to prove the Pythagorean theorem? Okay, so we have this picture drawn here. We've got a square of side length c inside a square of side length a plus b. Okay, now these are all 90-degree angles, okay, because this is a square out here, and we made this a square on the inside. Those are all 90-degree angles as well. Okay, so here's what I can do. I can find the area of this big square. That's going to be the base, which is a plus b, times the height, which is also a plus b. Okay, so that area is going to be a squared plus ab plus ba, which is the same thing as ab, plus b squared. Remember, I'm foiling this right here. So a times a times b times a, b times b. That gives me this. So this is a squared plus 2ab plus b squared. Okay? Now, what I want to do is I want to take this and subtract off these 4 triangles. Okay, so what is that? That says that if I take that triangle, remember a triangle is half the base times the height. So I don't want equals here. I'm going to subtract 1/2 the base, which is going to be a, times the height, which is going to be b. That's going to be this triangle right here. I'm going to cut this off of this whole entire area. Now, there's 4 of these triangles that are all identical. Base is b, height is a, base is a, height is b. Same thing over here. So I'm going to take this times 4. Now, if I take the big square and I cut off these 4 triangles, I am left with the square that's left in the middle. Okay? So let's see. This is a squared plus 2ab plus b squared minus 4 times 1/2 is 2ab. And now this and this cancel out, and I'm left with a squared plus b squared. And that is equal to the area of this square right here, which I already know is base times height. That's c times c, which is c squared. And so I've proven that a squared plus b squared equals c squared. Okay, so how do I use this? I'm going to use this to find x here. So this is the leg, this is the leg, this is the hypotenuse. So in this one it tells me that 5 squared plus 12 squared equals x squared. So we know that 5 squared is 25. We know that 12 squared is 144. That equals x squared. So x squared, I just move this to this side because I always like to have my variable on the left side. 25 and 144 is 169. And then to solve this, I'm going to square root both of these, so I get x equals 13. So I know that the hypotenuse here is 13. Okay, when the 3 sides of the right triangle are whole numbers, in this case 5, 12, and 13, that is called a Pythagorean triple. Okay, so 5, 12, and 13 is a Pythagorean triple. Okay, why don't you take a second, pause the video, and do this one right here, find out what z is. Okay, so in this case, the leg 1 is 3. I'm going to square that. I'm going to take leg 2, that's 4. We're going to square that. That's going to equal the hypotenuse, which is z, which we're going to square. 3 squared is 9. 4 squared is 16. That equals z squared. So z squared is 9 plus 16, which is 25. I'm going to square root both sides of this. That tells me that z is 5. This is a very famous 3, 4, 5 right triangle. Okay? This is the only right triangle that exists that is 3 consecutive whole numbers. Okay? A lot of times people, for some reason, think 1, 2, and 3 makes a right triangle. It does not. 1 squared plus 2 squared would be 1 plus 4, which is 5, whereas 3 squared is 9. Those are not equal. Okay. Now on this one, we're not finding the hypotenuse, we're finding the leg, and I'm betting you can probably figure out how to do that on your own. So why don't you pause the video, give that one a stab, and then jump back on and see how you fared with that one. Okay, so in this one, my leg y squared plus my other leg 60 squared equals 61 squared. So of course we all know that 60 squared is 3600. And I'm sure you all know that 61 squared is 3721. Okay, we're going to go ahead and subtract 3600 from both sides. And we get y squared equals 121, which implies that y is 11. So that's 11. So hopefully you got both of those. Okay, a train track is formed out of steel rails 100 feet long. In order to take into account the expansion of the steel and the heat, they are separated by gaps of 1 inch. A 100-foot-long steel rail will expand up to 1 inch in the heat. Okay, show mathematically why this is necessary. Okay, so here's what we have. We've got a piece of train track right here. It's 100 feet long. We've got another piece of train track right here that's 100 feet long. Okay, and we know that this will expand in the heat 1 inch. So let's do this. Let's convert these to inches. This is equal to 1,200 inches, and this is equal to 1,200 inches. Okay, now what happens is If this expands 1 inch, it becomes 101 inches. Now what's going to happen is these two steel bars are going to push on each other, and they're going to do this. Okay? Now 1 inch over 100 feet. What's the big deal about that? Well, let's take a look. This, we'll kind of exaggerate this a little bit. Goes up like this. Okay? This is now 1,201 inches. How high is that? So these are going to buckle like this. Okay? So we want to find out, is this a big deal if that does that? Okay, so we're going to use the Pythagorean theorem here. We're going to say that 1,200 squared plus x squared equals 1,201 squared. Okay, so this is going to be 144 with 4 zeros, so 1,440,000. Okay. Let's see, 1,201 times 1,201. This is going to be 1,442,401. So I'm going to go ahead and subtract this from both sides. And I'm going to get x squared is equal to 2,401. And then I'm going to square root that. So the square root, 2,401, square root that, that's 49. Now that's in inches. Okay, so if you think about that, that's 4 feet, 1 inch. That track just buckled 4 feet, 1 inch off the ground. That's about waist high right here. Okay, what's going to happen if a train hits that? Well, it's going to derail the train. Okay, so what they do is they put space. They put a little coupler right here, and they put space in there so that when that expands, it does not quite touch the other track. Okay. So here I got a nice little worksheet for you on radicals and a worksheet on the Pythagorean theorem. Have fun with that. I will talk to you guys later.